Okay, here I will present you something we call the classical natural language processing, which is not being a part of the modern AI systems because they use a different approach. Yeah, it's not yet. So, first of all, as you perhaps find out, this user interfaces, they are part of the IoT, right? Maybe not industrial, but the home automation for sure. So the most common is a mobile phone, or this home assistants, or eventually some user interface, like for example, there's an LCD screen on this sensor and the controller over there on the wall, right, the white one. So either this controller is as simple as a single LED showing red if something is wrong, like for example, it shows you that your vacuum cleaner has disconnected from network and cannot operate. Or is it quite complex? You have a rich user interface with graphics, animation, and so on. The visual part is one of the game. The second part is voice, right? And the third is touch. Touch is not very common. It's more for gaming because it requires complex devices, like for example those gloves that they make you feel like you are sensing the touch or tension. So definitely not for the IoT, but the first two, like vision and voice, they are very common in case of the IoT. So, speech and language, it's a method of communication between complex species like we do right now. We have different languages. We can talk in English, maybe in Polish, maybe in Japanese if someone speaks, maybe in Chinese, right? French, German, Spanish, yeah. Human use semantics and context. So depending on language, its complexity, there are many factors that they require not only understanding of what was being said on the textual level or understanding of the sentence, but also having a context, which is actually the biggest problem so far with the AI, right? Just to have a context. Because sometimes you say that, for example, I'm not feeling good today, but regarding your previous speech, it can be related to either you didn't sleep well or you were overloaded or maybe you're sick, right? But so that depends. So we use semantics in the context. We suspect that some animals, like for example dolphins, they also use semantics. It's not been proved, but it looks like, right? Some primates, they use contextual-based communication. So some sounds may have a different meaning regarding the situation, right? So for example, if you are having some bad words, it may be offending, but it may be for fun. It's all about understanding, context understanding, and ambiguity to some extent, right? So it can be ambiguous, just a sentence, but regarding the context, then you have a full view of what was intended to be communicated. Okay, quite a good example was C3PO, right? He had different languages, so he could. It announced itself like a C3PO human-cyborg relations, right? So many languages, many communication stuffs, and so on. So natural language is for living organisms. Right now, we would like an IoT ecosystem in the future to communicate on the semantic-based communication. We talk about this on the networking, right? We would like to have on this high-level communication, let the devices come, meet, and greet. However, nowadays, they all use meshing protocols. We spent on that a separate lecture. We are talking about this ISO-OC, about TCP, COAP, MQTT, Bluetooth, Zigbee, Threads, and many other protocols. So, the serious problem is that either we want devices to understand natural speech, or maybe to make devices to speak semantic and contextual way one to another. Imagine, for example, that you come here and you say to the sensor, oh, it's too hot today, right? And then the sensor needs either to make a communication with those valves that are on the heating system there to close them, or maybe they can speak to them and say, there came a user and it's too hot here, so please do something about the temperature. So they roll and they shut down, right? This is the future. But nowadays, we struggle with this one. So, this is all about converting speech into the protocol and protocol to speech. We want the person that is using a system to feel comfortable. The development of the voice-related technologies has been booming over the last 2 years. So, majority of the companies, they are using these automated VARs, right? This telephone answering machines that they are some sort of the synthesizers and they can understand you. Honestly saying, they are not very contextual. You can just give them simple questions and they will ask you simple pre-trained answers. But we already know the situations where the context understanding was not working well. I mean, it was like just a couple of days ago, a court in the US agreed for the person because the person was discussing with the chatbot on one of the airline companies, and it just make this bot to send him airfare tickets for $1 for a very long distance. So he used such a complex sentences that finally the chat agreed and said, okay, fine, and sold the tickets. Obviously, the company tried to block it, but the court says you're responsible for the chat, so for the bot that is working there, so you have to validate those tickets and let the user fly for $1, right? So this sort of, as you see, this sort of proves that this development is still ongoing, right? Those systems are not perfect. Honestly saying, 68%, as I read yesterday, as in case of the 68% of cases, the Finnish is contacting a human operator anyway. So it's less than half, right, that has been solved automatically on the speech IVRs. So we need to have a speech synthesis in this contextual understanding. Speech synthesis is solved, it's nowadays quite easy, right? Quite well done. Contextual understanding, it's more problematic. Okay, let me show you an old-fashioned way how to do that. Okay, there's actually the list of some most prominent services that you can use. And some software, which is open source for a variety of platforms and the commercial ones, and devices, right? Amazon Alexa is close to its end of life because Amazon decided to close this project, as far as I know, so they no longer sell it. So the traditional speech recognition system works the following way. First, it makes a speech signal, which is just like a wave. First, to make a future extraction. Then it hits the speech engine, which has been fed by the language model, because we use different languages, right? English is different than Polish, and definitely different than Chinese in the construction of the language. So we need to have this language model, which is like a pattern on how the sentence should look like. We also have something like an acoustic model, and this acoustic model can be done with the adaptation. So it's like a closed loop with the feedback. The output is then the transcript that you can later on analyze, but it also should be like a contextual transcript, so it's just not like a sentence, but also in the context of the previous one. It can be done on this level, but usually it's done on the separate AI-based solution. So the future extractor, the very one on the top, it's responsible for simplifying the signal to extract only critical features, not whole the speech, because the speech can also contain like noises, unnecessary vowels, and so on, right? And everyone is speaking a little bit different. So we use features that are common for a sentence. An acoustic model is a definition of word that realized as a sequence of features. So we do not analyze all the speech, but just these features that we have extracted. So this model is very simplified in this case. A language model is a probabilistic model to the words and word sequences. So what I mean here, it uses a statistical approach, or what is more probable than what is not so probable, in case the future understanding is not perfect. So it can help to improve an accuracy, right? But also deliver you general rules. Okay, so how it works the other way. You have a text and you want to let the text be spoken. A very elementary system that we used to have on railway stations, on communication centers, they were working the way that you actually compose and predefine sentences using just spelled words. It sounds very unnatural. Nowadays, it works quite good, but the principles are different, so the full speech is done more or less the same. So you have a normalization of the text, then you have a conversion text to unit, and text to prosody targets, which are defined in the model. And then you have a segment selection based on the database and post-search modification, like, for example, intonation. Right? So prosody models, they may have rules for intonation, for accent, for vowel length, and so on. The database provides the rules of generating different sounds for same segments. So, for example, you may have words that on text they look the same, but in speech they're different. It depends on the language, of course, right? But yeah, they do. So it works like a different etymology or origin of the words that may have it from origins from French or from German in English. Okay, so how to? Well, honestly, we use already services for that. Because now the end node devices are becoming to be capable to make online or offline, sorry, offline live understanding of at least activation voices or actually activation words. But majority of the recognition is being done by the external service because it requires quite a decent computing capabilities, which is not the case in many of the edge class devices. So you can have, like, for example, a Raspberry Pi with this piano hat, which is and a microphone interface, in short. Then you can forward it to obtain the audio file, and you may use, for example, Node-RED to make an MQTT interface. So you send this audio file to the recognition platform, which can be, for example, IoT Watson, but it can be any other, right? Just the question is, what is an API here? Watson is great because it has another, like a Node-RED here, so you can easily bind it one to another. So you go over MQTT. So just to implement it, it's more or less this kind of the structure, right? So you have a cloud service, you have this Home Assistant user interface, whichever device is that, and then you have this Home Assistant operating system which controls sensors and the actuators. So you can ask for the data, and you can also give a commands, for example, open the window or close the door, whatever it is. So you show it in the case of the Alexa, right? Okay. So there are some challenges. First, security, right? So correctly identify user with their voice. As you saw, it's a problem with the laser, right? So yeah. Safety, avoiding dangerous actions like here you have on the right, right? And provide a correct accuracy and prevent user from inappropriate actions, inappropriate activities, like in this case. Second, it should sound and behave and act like naturally. So you would like to speak to the human, not to the machine. I don't know how it's about you, but I'm really not very keen on talking to a machine over the mobile phone because they still don't work naturally, right? But I will later on show you something. Performance. Do not delay in answer action, right? So you send a request and you wait 30 seconds for the reply. It should be instant. Or if a result is not available, you should act the way that it's thinking. This is something like actually the system from Google does. I wonder if you have experienced that. So we'll see it in an example. Okay, so there it is. By the way, it's about Alexa.
show me a recipe for a grilled cheese sandwich.
You're 32 years of age and you don't know how to make a grilled cheese sandwich. Its name is the recipe.
Like, how far is Mars?
How far is Mars? Well, I'm possible to go. I've never been there. This is not even Mars. It's not even oxygen here.
What's set the mood?
Now setting the mood. You're in the bush, and you're just so dirty and so sweaty because it's hot in that bush.
Let's rebush, reboot. What's the first country music?
Oh, dance now. Let me find you.
No, what's the country music?
What's it called, Brandon?
I'm afraid Brandon is a little dried up. But do let me know if there's anything I can help you with. Jessica.
Here we have an example of the personalization, right? And
Thanks, guys.
so, as you see, there are some challenges, maybe not directly related. So, another thing is cross-language translation, which actually was quite considered to be well done by this recent Samsung update for this Galaxy series, right, Ultra, that is able to translate the speech in the real time in between. But I wanted to show something about this natural language process complexity in the Europe, but actually how the languages are far one from another. There's like a famous lexical distance map that is showing the differences between the European, not only European, but generally European languages. So as you see, Polish language is, this is Silesian dialect. Polish language is close to Czech and quite close to Ukrainian, even if the Ukrainian is written in bookfast. Lexically, it's short. Slovakian is a little bit farther than Czech, so I'm surprised with this one, but it looks like. But in this general region here, we also have Bulgarian, the Serbian, Horvatian in Bosnia, Slovenian, and Russian, right? They are Slavic languages, so they are similar. But for example, the languages which are like Hungarian, Estonian, and Finnish, they are totally different in the speech model, right? So they are totally different languages. So here is a full map. Like French, Italian, Spanish. Here are English, Netherlanders, German, Danish, Swedish, Latvian, and Lithuanian. They're like separate, and so on. Okay. Yep. So that seems to be like all about the natural language processing in the interfaces. Yeah. Thank you.